Hey guys, what's up? Eddie Aho here with KissAnalog.com. Yeah, you might be surprised we're not doing a Class A audio amplifier review. I've got a Supco device here. This guy's from Redfish, okay? What I want to do is show you this guy. That's how they packaged it. Just wanted to show you that. We're going to bring you over the bench. We're not going to waste any time because this might be a long video. This is not just a current clamp meter, but this is a power quality device. It can measure power factor, total harmonic distortion, your power line, and that's really cool. The power factor by itself, just measuring power factor, I think is super cool. It is safety certified from ETL. And it has a really cool app that works with it too. So let's jump into this video, not waste any more time. Alright, thanks guys. Alright guys, so this is the box that it came in. Nice box, right? Here's that software that it works with. Yeah, same thing on that side. This side here actually has a bunch of information here. If you want to pause that and read that, but look at the specs. Very nice specs. DC tolerance down to 0.5%, AC tolerance 0.6%. Really nice. Now it is a 6,000 count. Another really nice feature is the IP54 rating for ingress protection. So you got good dirt as protected up for splashed water, and you know it meets the standards here. Where is it? Down here, ETL. So ETL's the safety labs that tested it. Here's the software. That's what it kind of looks like. We'll take a closer look at that. Let's slide this thing out of here. There we go. Nice. That's a nice looking meter. You know, that's nice because it's good colors to stand out, so you don't leave it on a work site, and it's going to be probably different than, you know, other people carrying yellow meters around or whatever, so you'll be able to spot your meter. And then kilowatts or watts. So that's what I think is super cool about this particular meter, is the fact that it can do those things. So we got our Cat 3 1000 volts, Cat 4 600 volts. Everything's nicely marked. So we have a relative function, and here's a hertz or percentage. This button isn't for this, but it's for when you're in volts or AC up here. We got a hold and a backlight, but besides the backlight, you also have a flashlight. And I believe this flashlight only works whenever you're using the jaws. So to help you see, you know, if the wires are in kind of a dark cluster or something, it kind of helps you see to grab those wires. So it'll work in the wattage or the amps. And then a min-max function. So it's the iDVM550. And you know, as I'm holding this, I just like the feel. It has a rubberized, you know, not super soft or anything like that, but it is rubberized. Here's another thing it has to have is the FCC, because I kind of skipped over it. It has this Bluetooth function with the range key. And this is the function key, which I'll show you how that, when you're going to want that. You're going to want that when you're doing power measurements. Now, one thing to point out on the jaws, there's these little lines here that you'll see on just about any brand. And that means that, you know, the best place to put the wire is between those two lines. So it's kind of in the center of this loop, okay? You don't really want it laying against it up here or whatever, but, you know, you pretty much want it in the center. I mean, you can't take a measurement. It's just to get your best accuracy. Okay, and this little protrusion here goes with the NCV, so that's nice. It's nice protected and very obvious where you're supposed to, you know, like some multimeters, you just figure it's around the top somewhere. You don't know if it's on the top front, top back, but when you have something like that, you know exactly where it is. And here's the lines on this side in case you're reaching. So sometimes you might be reaching at a panel or something. You won't be able to see, so you'll just sit there for a moment and then hit the hold button. And then release, come out, and then you can go through your function and look at all your readings. And these are nice. You always get the softer ones down here, and then they're a little stiffer up here and these features here make it stiff. So up here it's kind of stiff, and down here it's a little softer. But that'll hold your leads in place. You know, a lot of guys just open up the jaws and wrap their leads around it, right? Alright, I'm just looking at all the features. I see a little feature down here, I'm not sure what that's for. It does have a QC sticker, of course, so that's kind of cool. And one screw to remove the battery compartment, and it looks like 3 screws to remove the 2 halves. Whoa, let's see what else is in the box. Alright. Okay, this is cool. Here, let's pull. Alright, let's get rid of the box. You know what? This is really neat. Because it can read power, you have these little inserts. You know, even on meters that don't have power capability, it'd still be nice to be able to read the voltage this way, right? Stick your probes down in those little holes. You plug this into one side, right? And then you plug your device under test or whatever into this side. And what this is, 1x or 10x. So it's marked on both sides. That's great. So in case, depending on where how you have this plugged in, you might not be able to see it. And if you forget which one's which. But yeah, here it'll give you a 1-for-1 reading. If you have 5 amps going in, it's going to tell you 5 amps. Here, this guy's going to amplify it by 10 times. So if you don't have a lot of current going through, you can use this guy because over there you have 60 amp is the lowest range, right? So you can use this guy, and essentially that turns into a 6 amp range, because now 6 amps looks like 60. That's a pretty nice splitter right there. And that is super cool. They give it to you with the meter. Okay, first of all, I was just looking at this pouch. It's wow, look at all the stuff in it. Okay, yeah, so this guy easily fits in there. This is a nice pouch. It's the canvas on the outside, which I like. I actually like that better than the plastic. You know, it just gives you more grip so it doesn't slip out of your hands. If things are getting wet, you put your meter inside, and then you have something to kind of grip onto. But yeah, here we go. And you know what? I'm just looking. Those are threaded. Oh, here we go. Here's the boot. So, but that's nice it came out of it so I could look at it. So that, first of all, it's solid and it's threaded. And the hinge, you can tell it's not, you know, some of them you could go like this and just bend the crap out of them because they're so cheap. But this one's a nice solid one. And then, yeah, the rubber's soft enough that you can pinch them, but not so stiff. I mean, it is fairly stiff. Okay, and then your leads. Alright, so from what I can tell right now, they are PVC. Wow, the red one's a little bit bigger than the black one. As far as wire gauge, at least, it looks like. Or maybe that's insulation. Wow, those things are on there tight. Holy cow. Some they just fall off. But yeah, those go on there stiff. And then yeah, this screws on, so you got a nice secure clamp. Okay, and then we got our 9-volt battery. Yeah, so I can tell these are PVC. They don't look like they're super stiff or anything like that. Yeah, so that's what you get. So they're not, you know what, these aren't the most pliable leads I've seen, but they're not the stiffest ones. I can tell you what color I found get the stiffest ones with, but never mind. Oh, that came off a lot well, I was going to say it came off a lot easier if I twisted it. Yeah, it seems like it does, instead of just trying to pull it. Okay. Oh, you know what? Duh, this thing's threaded. Holy cow, no wonder. Oh, that's cool. No wonder it's so hard to pull off. You know, I don't think I've seen a threaded one before. Well, that's nice, because that does hold it secure. I was like really pulling on that thing. Okay, this guy's all wrapped up so it doesn't short. Okay, there's that screw. It's machine threads, and I could tell that it's in an insert. You could just tell. There's the ETL logo, by the way. Third-party safety test. Oh, there you go. Look, this sticker's kind of covering up, but there's a little lip down here where you can get your finger in there. So, there's the feature here. It's pretty big. It's got a couple ribs here to make this strong, but it's just the way it's shaped. you know, that's going to be a strong piece of plastic. Okay, I like that. The compartment is isolated from the PCB and everything else, so you're not getting a lot of junk into your meter. I mean, I can see a PCB right down in through there, but so obviously these guys are staked right down the PCB. Okay, you know what? Let's just go ahead and open it while we're here. There's probably a clip up here. You know, first time taking the meter apart, I like to be super careful. Oh, there we go. Because I hate to tear something apart. Wow, that is looking pretty nice, I think. Holy cow. Look at the size of that MOV. That thing's a beast. Holy smokes. I'm sure that's the biggest one I've ever seen in a multimeter. That is a monster. It looks like another MOV with this gas tube. I'd almost think that they might be in series. But that's a nice gas tube. That's a big gas tube. And then look at these PTCs. And I'm not sure what the yellow guys are. If they're other PTCs, I think they are. Wow, that's very interesting. And then we have our MELF resistors. Holy smokes. Look at this. We have two crystals here. And we have these little jumper wires. I'm not sure those are guys. It looks like they're going through the board to the other side. Okay, I'm looking up at here at this big spring. Now that's a beast, huh? Let me get the camera a little closer. Alright, so I wanted to get the camera a little closer because, you know, I'm really impressed with the controller chips, with just everything they're doing here. It's a nice layout. I like the way these clips are soldered into the board. But man, look at all these ICs in here. And we have some kind of big resistor up here. Okay, this has to be the Bluetooth module. And by the way, while we're looking over here, see the battery compartment sits down on top of the chips right through here. Essentially what it's doing is all this stuff around here is sitting around the back of this. And then see how this guy comes down right down in here? So it's separating, in case something were to happen, it's kind of protecting all this circuitry from all this stuff. We have our buzzer, and there's another crystal. So there's a lot of stuff going on in this little meter. Holy smokes. But I do like that big spring. There's an aluminum electric capacitor kind of hidden up here in the corner. So they used a pretty large one. They placed it in a nice spot that's kind of safe away from everything else. We have another MELF resistor. Look here, these must be for our high voltage. There's 1, 2, 3, and there's one kind of underneath this PTC. Wow. Alright guys, with the little wires going off here and the little wires going off there, there's a display on the other side. There's probably not much else. You know, I'm sorry, I'm not going to take off the 1, 2, 3, 4, 5, 6, 7, 8 screws. Yeah, it looks like there's 8 little screws to take off just to see the display. So I think we're going to forego that, okay? Let me know what you think about that. But I can see all the protection circuitry up here that people like to see. And, you know, there is just an incredible amount of electronics on this board. See these little yellow guys? These are tantalum capacitors. That looks like a transistor, another diode, and then, you know, you have all these chips up here. It must be for this power factor stuff. There's just a lot of stuff going on, and I'm assuming it's because it does power and power factor. Alright, just wanted to give you a good close snapshot of that. And then also the Bluetooth chip. Alright, it looks like it's a TI chip, the big chip. M430FG4618 Rev G. And then the smaller one next to it, that looks like a DTA066IL. You know, let me know if you guys know who the maker of that chip is. That doesn't look familiar to me. Okay, and there is an 8-pin chip. Can't really tell if that, I think that's a Fairchild, but I'm not positive. Okay, there's a couple more 8-pin chips. See the tantalum capacitors between the yellow guys? By the way, the tantalum capacitors are not inexpensive. And they have a bunch of little ceramics, resistors, and these tantalums. There's some transistors there. That's another TI chip. What is that? V2252A, 2442C. Okay, there's that chip. TLO 60 something. That's an op amp, I think. There's some 0 ohm resistors, it looks like. Some more of our MELF resistors. Then that guy's going to be hard to tell with the value at that. It looks like a small ohm value though. And then look at these 3 chips. HC4051s. There's another V2252A. And there's the battery terminals. So they look like they're put in by 3 stakes. That's nice and solid. And there's those interesting looking crystals. Can almost read the value, 32 meg I think. Our buzzer next to the other crystal. Not sure where that 8-pin chip is. Looks like some more transistors. There's that gigantic MOV. That's our gas tube. And there's another MOV, smaller one there. That's usually what you find in these things. And then our PTCs. Got a couple big ones and then a couple smaller ones that are really interesting. The big ones are really big. This guy here is your Bluetooth device. Yeah, I almost forgot to point out this kind of tongue and groove thing. You know, you got the big stiff thing here, and it's kind of rubberized down here where this rubber comes up. Same down here. So this kind of fits down into a channel right here. So yeah, it's a pretty narrow channel. I mean, it's a tight fit. You might have been able to tell, you know, how much I had to kind of pull. But man, it fits, what do they say, fits like a glove. And with the top on, it is just solid, even without the screws in. I mean, there's no wiggle to it or anything. It's solid. This is a Golden Peak battery. It's a Japanese company. It looks super heavy duty. I think these are well-made batteries. So this compartment though, you know, shows the battery in there, plus minus, pretty good picture, but it looks like this is a wider opening, this is narrower, so it looks like it won't fit in there. And just put it in properly. Whoops, let's see how it goes. Okay, it's like, wow, that's a nice tight fit. And by the way, one thing about this big large hole and the way it fits around that terminal down there is when these little things hook in here and then you have to push and set it is in there tight. All right, we got the batteries in. Let's try the first thing. Let's get the current. Okay, this is 1,000 amp. Let's go down to 60 amps. I think that's going to be probably a little more useful right now. So we're going to try this guy out here. Let's move our case out of the way. Alright guys, I got a little setup here. We're going to turn this guy on. We're going to try the first thing out. Well, actually that's 1,000 amps. Let's go down to the next one. Well, we're in automatic, but we can go from 60 to 600 amps. Okay, we got a little motor here, powered by this power supply. DC power coming off right here. And if I can pull this back so you can see it. And the AC power coming in right there. Now, because I have this breakout power cable, I can just come over here and clip onto this. Now I've got this pot turned all the way up, okay? So maybe you'll be able to hear that motor when it turns on. Okay, we got 0.9 amps. Not a lot of current, a little bit. Okay, this time I'll tell you what we can do. Let's turn it off. Let's hit the Inrush Current. Little INR comes up here on the display. If you can see that little INR there, maybe. Nice backlight. It's a little bit hot spots here, but still it's not bad. Very nicely lit. Okay, let's go ahead and turn on the switch. Alright, we captured about 1.81 amps. Pretty cool. Okay, let's turn off the backlight here. Now I want to try something else. This little guy that came with it, that's so nice, it has a 1X and 10X, and then it has a place to put your voltage probes, right? Well, let's just go on the 1X. Turn the meter around. Here, I gotta clear that thing. Okay. Back to auto hold. Okay, let's go ahead and turn it back on again. Okay, there's that 0.95 amps, I guess, somewhere around there. Okay. Now let's go down to this 10X setting. So if you had a small current that you needed a little bit better resolution, then you could go to 10X and let this thing amplify the signal for you. You just have to remember to divide that by 10. Okay, just for fun, let's try this. Let's go to Inrush. And let's go ahead and hit that switch. Okay. We got 22, so that would be 2.27 amps. Let's go back to the 1X. Ready to go again? Okay, we got just over 2 amps, just like, yeah, I was just wondering if we might get a better reading if we go here. But I think this current's high enough that they're both working probably, you know, we're probably tried a bunch of different times, get a bunch of different readings, but that looks pretty good, right? Okay, now let's try something else. Well, we can measure volts. Let's try doing volts. Okay, nice positive click when you push them in. They snap in there pretty tight. These things screw off again. I have to remember that. That's pretty cool. Usually they just pull off, right? Okay, now it's labeled line and neutral. So I'm going to put the red in line, black in neutral. And we got 122.8 volts. That's pretty neat. You know what? I'm going to try to do a minimum reading. First time I push it, takes it into max. Push again, minimum. I'm just curious when we turn it on if it makes the voltage droop. Yeah, maybe a little bit. 121.7. Let's turn it back off again. Yeah, it might have dropped a little bit. Let's go to watts. We're going to have to put this back into the loop here. You know, I could go through there, but I'm going to just go here this way. That way, the wire, you know, that way I can set the meter like this so you can see it, okay? Okay, there we go. Had to get the leads pushed in there a little tighter. Okay, so we're about 122.6. Let's turn on the switch. Okay, see the power? That's watts. And that's milliamps. Okay? That's VA. And okay, that's the power factor, and it says leading right there, so it looks capacitive. That's because of the capacitors in here. Okay guys, so we're reading watts and current and volts. Now when I push this, these two stay the same, and this gives me VA reading. And it says it's leading, so it looks capacitive. 118 volt amps. Push again. Cosine, so the power factor is about 0.6, and we have 94 VAR, that's reactive power, and then that's the degrees, 48 degrees, and we're back to volts and current down here, and then we're back to watts here. I want to show you something. Here, if I hold this down, now we go to current, okay? Now, right here, we got 60 hertz, volts, and volts, right? If I go again, we got volts, but this is a harmonic, 100% on 01. And then 01R is about 2 or 3%. That's the first harmonic. and then 3%. That's pretty cool. So you can see harmonic distortion as well. You can see how it's spread. Alright, let's go non-contact voltage here. Obviously it's reading something. Okay, let's pull this out. That's nice light, and you can hear the beeper, I think. Okay, that's DC voltage. A little different sound. And we get one dash line right here in the display. And then we get all 4 dash marks and fast beeping. Yeah, that seems to work pretty well. And what's nice is you know where to touch it because it's right here on the end, right? Yeah, that's a nice feature. Now, hey, I wanted to show you something. Let's go back to current for a minute, okay? Let's turn this on. Okay, we have that going. Now, I'm going to grab the red wire. See, 0.9 amps. Grab the black one. 0.9 amps, you know, roughly, right? Okay, now I'm going to go around both of them. 0. So you never go around both. One of the wires is making a magnetic field in one direction, and the other one is return current, and it's canceling. So remember, you can't grab both wires. That's why I say you have to have a breakout cable like this, or a nice little gizmo like that. Okay, let's go to the continuity and ohms and all that. So this is ohms right here. Alright, I'm over here on my decade box, and so I'm set down. You can see it's down really low ohms, right? Now I'm going to pop up my 100K switch. I'm going to pop it up a few notches real fast. And you see how fast it pops up. And then drops back down. So now, you know, one thing, if you're trying to capture a reading real quick, is use your manual range. So this meter, you can manual range. So that's, you know, nice thing about this button right here. Alright, let's go to, okay, that's diode check. Okay, first thing I want to do is see how many volts that thing puts out to check diodes. Okay, wow, that's good. 3.2 volts. That's great. That means we can check a lot of different types of diodes or LEDs. Okay, let's check this guy here. Alright, that's a Hioki, so that looks right. Should be pretty low. And if I reverse polarity it, it's open. Now, one thing, I didn't hear a beep. So it doesn't give you that little chirp or beep that some meters do. Okay, so it's able to do that. Let's check this guy out. We'll just jump right to the blue. Look at that, 2.5, that's great. Green's 2.2. Red's about 2.3, I guess. Green is 2.2. And the white is 2.6. Alright, so it's able to do a bunch of those. That's great. Let's go to, oh, that's continuity. You can hear the tone. So it's pretty fast. I mean, sounds fast to me. Okay, let's go to the next one. And let's just check out some capacitors. Alright, that looks good. These are pretty small value capacitors, just trying to see if it reads the small ones. And then up to 10 nanofarads, this should be 1 microfarad, I believe. Yep. forget what these guys are. Oh yeah, so I think they're 4700 puffs, so that looks about right. Okay, then here is a bigger cap. Alright, so 0.9 millifarads. So 1000 microfarads, that's what that cap is. Okay, I was just checking the specs again, and I mean, it's crazy. This thing goes up to 100 millifarads. That's just, and then down to 10 nanofarads. We saw that it went below that. That's the range. These are the different ranges. So we had 1 nanofarad that it was able to do, right? Okay, it's 890. It goes to those small values, and then here, let's move this out of the way. And I got this big capacitor bank, and because they're in parallel and it has these discharge resistors, I usually read, it's been a while since I've done it. I think it's like 20 millifarads, something like that. Here, let's get these in the right polarity. Whoops, slipped off. Oh, 26 millifarad. Wow, I didn't know if it was doing anything, but yeah, that's okay. That's about what I get out of this. Is I remember it was right around that area, 20 millifarads. But okay, so that's pretty impressive. All right, and for frequency, we're 999, so 1 hertz. I've got this thing set for 1 hertz, and it's supposed to go up to 10 megahertz. So it looks like it does a great job. 10 hertz is the smallest range, but that's 1 hertz. We can do that. Let's do 9 megahertz. Okay, now my amplitude, I wonder, I'm at 420 millivolts. I wonder if I need to be a higher amplitude for that to read, because it's supposed to read that. And okay, so it looks like it needs to be about 2 volts RMS, and then I get the reading. And that's supposed to go up to 9, almost 10 megahertz. So here, I'll just plug in 10, see if we can get there. Now, it might not, oh, it actually did. Wow, okay, it said 9999, so I didn't know if it'd go that high. Okay, that's pretty cool. Okay, I just want to show you the display. 6,000 count, right? So I'm bringing up the voltage nice and slow. And once we hit 60 volts, we'll lose a digit. There it goes. So it went up just, 62 volts maybe, and then it moves. That's a 6,000 count meter. Okay, there we go. So down around 6 volts, you get about the same thing. 5.2, you get 3 digits. And then once we go over 6, you'll lose one of those digits to the right. The decimal place will move over. Yep. And then you end up 2 digits. So that's what you get with 6,000 count. Which is, 6,000 count's really good. Alright, just cover all the bases. I've got it in DC. You see the DC setting. I had to hit the function key to switch over. And again, we'll see it go from, where we are now to losing a decimal spot. Yep, right there. Alright, so let's say you're charging a battery or something like that. Anything you're looking at, current voltage, you can hit the relative. See, let's say we're 11.83. We don't want to memorize that. We just want to see how much we charge. So we hit the relative, and then when things start to change, we'll see, oh look, we've charged 0.2 volts. Oh, okay. So you don't have to remember where you started and where you are. You can just see the difference, that you may have charged over an hour. And anyway, so yeah, there's a lot of different ways to use relative. Okay guys, I'm in a situation where I've got my instrumentation set up, my voltage probes, my current probe, my clamp on, so I'm going to capture a power measurement, but I can't see my meter. and maybe even I don't want to leave power on too long because something's heating up, some kind of problem. So I can go ahead and hit power, wait until it stabilizes for a few seconds, and then hit the hold button, then turn it off. Then I can safely take a reading. I've got my reading here, 73 watts, 122.9 volts, 966 milliamps. Okay, hit the function button. Now I got VA, 119 VA. Hit it again, and then that gives me my power factor, 61.8, or 0.618 if you want to look at it that way, and 93 VAR, so that's your reactive power, 93. Okay, and it's 47 degrees, the phase angle between the real power and the parent power. And it says it's leading. The phase is leading, so it's a capacitive load. Okay, back to 73 watts. Pretty cool, right? And then I can look at my harmonics too, my current harmonics. Hold that button down for a minute and it switches over. And then I get this peak value. Yeah, I kind of wonder about that, 176 volts. Oh, that's probably the peak of my waveform. That sounds about right for 122 volts. Okay, and then my first harmonic. Alright, I'm not getting a lot of noise, I guess. It's mostly just displacement. Alright, well, that's nice to know. Yeah, that's nice to know. I love these features of this meter. Alright, this is a true RMS meter, right? So I've got a sine wave at 3 kilohertz. Okay? And we're already rolled off, so that's pretty good because I think the spec on this is 1 kilohertz. So there's 1K, and that's 1 volt RMS. That's correct. Now let's go to a square wave. That's the way you can really tell because, you know, square's not sine, and sine, yeah, so look, even with the square wave at 1 kilohertz, it's pretty darn close to 1 volt RMS. So let's go 2K. Yeah, that's not bad at all, guys. 3K. So yeah, this guy, you know, he's good. A good solid 1 kilohertz true RMS, sine or square wave, and even beyond that. Alright guys, I have this app. It comes from Supco Techlink. You just download it from your app store, whatever, and it works great. So you have a record button so you can record your measurements. It's really a neat setup. You can control this remotely. Let's just see how fast it connects, how easy it is. You don't do a pairing process, you just open up the app and hit that. And let's see, this is the first time I've hooked up to this meter. Okay, so I gotta go through a disclaimer. Sure. Alright, there we go. Look at that. So it's telling me what this guy sees. I'm hooked up over here with my voltage, so it's reading the volts. But now let's say I'm remote, okay? Let's go ahead and connect this guy up. And we're just gonna put this out of our way right now, okay? So we're just gonna look at the app. Let's just focus on that. Okay, so now I'm focused on the screen there. I'm just going to turn on the power. Okay, now we got a little bit of power going to our motor here. I'm going to bring up the, there we go. I don't know if you can hear that, but you can sure see it, right? You can see the amperage, the power starting to pick up. We can see our power factor. So you can look at capacitors under load to see if they're failing, and you don't have to actually, maybe you have a start capacitor that's hard to get to. You can clamp on the current, take a look at the voltage. You have to be at the current that's going over to the capacitor, and then the meter, once you run through one of these things, it'll tell you how to set up and what to do. Okay, clear existing data, yeah. So now, see, it's going to tell me capacitance value. So let's just pretend we're running a thing. So it's gonna, okay. All right, so it said 20 microfarads. So I'm really curious the capacitance value in this thing that would give that kind of reading. But that's just an example of the kind of things. Let's go back to tools again. So I hit the references here, and wow, there's just a lot of data. Look, here's our manuals right here. So our online manual. Okay, it takes us to the website. So there's the manual right there. So this is really super cool, guys. Flame sensing, HVAC school. So, you know what? This app doesn't cost anything. So, not like some companies that charge you so much money for their apps. This is free. So here's a list of the tools again. Voltage drop test per NEMA. Even if you're in school, this would be a great thing to go through school with so you can learn how to use these things in your class. But on the job, I'm sure this would be very helpful. Hey guys, so what do you think of this thing? The Redfish. Pretty cool. And thanks Redfish for sending it. That was pretty darn awesome. Now guys, oh hey, before I go any further, I want to thank my patrons. Appreciate you guys. You become a patron for as little as $1 a month. And I want to thank everybody for watching videos and commenting. That's always appreciated. Thumbs up, much appreciated. That helps the YouTube analytics and all that kind of stuff. Now, what I want to say about this meter is, I forgot a couple things. One thing is it powers off in 30 minutes. If you have the backlight on, the backlight will turn off in 30 seconds. And by the way, if you're in one of the current modes, like power or current, then when you turn on the backlight, you also get that flashlight, okay? And so I think the reason it's shooting right here the forks is so that when you're trying to go over a wire, you can kind of see what you're trying to get into, okay? Because maybe, you know, you're in a dark spot and you want to see the wires you're trying to get to. So I think that's smart. You might think, well, it's dumb because it's blocked. It doesn't shine out. I can't see what I'm doing. But the idea, I think, is when you open the jaws and you're trying to get onto a wire. I think that's why it's there. So 30 seconds, the backlight and everything turns off. Okay. Now, the other thing is this guy's lists for about $289, which that might seem expensive for a current clamp-on meter, but this is a lot more than that. I mean, for one thing, it has a safety agency approval, the ETL, so it's right up there with all the brand name meters. So right there, it's already in their price bracket. But when you consider that it also does power measurements, power factor measurements, well then this becomes very inexpensive, I think, because I know some other brands that cost, you know, you can add another zero to the price and to get power quality measurements. But you can do total harmonic distortion, you get your power factor, your, you know, so it tells your apparent, your reactive power, phase angle, power, you know, all those things. So yeah, and Inrush Current, and also that app. I mean, my heck. I mean, all the tests you can do on that, like if you haven't even thought about what you can use a meter for, because not a lot of meters can, I mean, very few meters can do all those things. So that app kind of reminds you of the kind of things, or maybe, you know, I mean, it's just going to show you a lot of things you can use this thing for. So if you're trying to look at capacitor start motors, fans to see if they're working appropriately, all that kind of stuff where reactive power comes into play, this guy can tell how much real power and how much reactive power, and so it can calculate values like capacitance values and things like that. Pretty dang cool. Now, this, the fact that it came with this was really neat, and also the bag. I think that was plus, you know, leads of course. And one thing I have to admit, I've had one of these on the bench for a few months. You may have seen it in a couple videos. Now, I've been using it for power supply development, audio amplifier stuff, and I've been looking at my power quality stuff. I've been looking at THD, but mostly what I've been looking at is power factor. You know, am I leading, lagging? I can kind of guess what I am, but what I want to know is how close to unity am I? how good's my power factor? So that stuff, yeah, I just think this meter sells itself, just the fact that it can do that. And that's actually how I found this. I was looking for a power quality meter and something affordable, which really hard to find. And I found this. So that's how I ran into these guys. So I want to thank Redfish again for sending this. And I do have one of their other multimeters. Now, again, that app is just incredible. The fact you get it for free and that it looks like it's really involved. There's a lot of good stuff. I'd like to know what you guys think. And yeah, fill in the comments below. Tell me what you think of this thing, okay? Thanks for watching, and we'll see you next time.